So guys, going forward, so let us do summarization of what we have discussed in this module so far. So if receiving machine receives a packet in which destination IP address exactly matches with the IP address of one of its local interface, receiving machine consumes the packet. So that we have already discussed that if the destination IP address that is specified in the IP header of the packet exactly matches to the IP address of one of the local interface of receiving machine, then that particular machine do not forwards the packet, it just consumes the packet. Why? Because if the IP address specified in the packet matches exactly with the IP address configured on one of the local interface of the machine, it means that the packet is destined to that particular machine only. Second point is that if receiving machine receives a packet in which destination IP address do not matches exactly with the IP address of one of its local interface but falls in one of its local subnet. In this particular case, the machine forwards the packet onto that subnet using L2 routing. Right? So we will discuss more on this L2 routing when we will be discussing L2 routing in detail. So you understood this point, that whenever a packet is received such that the destination IP address specified in the packet do not matches exactly with the IP address of one of its local interface, it means that the packet is not destined to that machine, but actually the packet is destined to one of the machine present in the local subnet of this machine. So in this particular case, the machine forwards the packet onto that particular subnet using L2 routing. So in the previous slide, when the router B receives the packet from router A with destination IP address as 10.168.1.3. Now this destination IP address do not matches with the IP address of any local interface of the router B. So router B do not consumes this packet, but the destination IP address specified in the packet falls in the local subnet of 10.168.1.0/24. So what will router B do? The router B will forward the packet out of this interface, and using L2 routing, the packet eventually reaches its intended destination. Now you can see that on machine C, the IP address configured on the machine C exactly matches with the destination IP address specified in the packet. Therefore, machine C is the actual consumer of the packet. Right? So these 2 points are important. Now the third point is that if none of the above conditions are true, in this case machine forwards the packet using L3 routing to the next router. This is the first action that the router can take. The second action is the router can also choose to drop the packet. So when will router choose the action 1 or when will router choose to perform the action 2? We will study this in detail when we will be learning L3 routing. But for now, just understand that if a router receives a packet such that the destination IP address of the packet do not matches exactly with the IP address of any of its local interface, and the packet neither falls in any local subnet of the router, in this particular case, the router can choose to forward the packet or it can choose to drop the packet. The router will choose to drop the packet if the destination IP address in the packet belongs to some remote subnet. And that particular remote subnet entry is present in L3 routing table of the router, right? And if that particular entry is not present in L3 routing table of the router, then router do not know where to forward the packet, right? So router is not the consumer of the packet, and the packet do not belong to any of the local subnet of the router. And third point is that the router do not contain the entry to the remote subnet to which the packet belongs. When all these three conditions are satisfied, then router actually do not know what to do with the packet, and in this particular case the router choose to drop the packet. So we will understand this concept in detail when we will be learning L3 routing. Now let us see the organization of a broadcast domain. So what is broadcast domain? A broadcast domain is nothing but a single wire to which two or more than two machines are connected, right? So such a wire is called broadcast domain. If there are only two machines connected, that is machine A and machine B, then this broadcast domain is more specifically called point-to-point domain or point-to-point link. But if on a single wire, if more than two machines are connected, then such a wire is referred to as broadcast domain, right? So this is the broadcast domain in which the machines A, B, C and D are present along with the router. So how does the subnet of devices look like? So you can see that this pink colored region is actually a subnet in which actually 5 devices are connected. 4 devices are host machines, that is A, B, C and D, and one of the interface of the router is also connected to this wire. So the second point says a subnet is always present behind the L3 router. Now the point here to note here is that each interface of an L3 router actually represent a subnet. So you can see that this interface of an L3 router represent a subnet. Let us call this subnet as A, right? Similarly, if there was another interface on the router, then that particular interface would have represent another subnet. Let's say that subnet is B. So the point here to note is that each interface of an L3 router actually represent a subnet, and depending on the IP address configured on that interface and the mask value configured on that interface, we can calculate the subnet ID, right? And all devices connected with the same wire forms one subnet. So in our subnet A, the machines or devices present are machine A, machine B, machine C, machine D, and the router itself is also a member of this subnet. Now the next point is a packet sent by one machine is heard by all the machines in the same subnet. So what does that mean? That suppose one of the machine present in the same subnet places the packet on the wire, and let us say that the destination of this packet is the machine C, which is present in the same subnet. So in this example, the communication is being carried out between the machine A and machine C. Now if the machine A places the packet on the wire, actually when the packet is placed on the wire, it means that machine A places electrical signals. So electrical signals are nothing but it is a varying voltage, but it is a high and low voltage like this, something like this. So high voltage represents a bit 1 and the low voltage represents a bit 0. So rest of the machines which are connected to the same wire, that is the machine B and machine D, actually detects these varying voltage or electrical signals which are being placed on the wire by the machine A. Right? So this is the property of the wire, that if any two machines which are connected to the same wire communicate with each other, then rest of the machines which are connected to the same wire also hears the packet that are being transmitted. Because at the end of the day, the packets are nothing but these are the electrical signals which are placed on the wire. Now the machine B and machine D, whether they want to detect those signals and wants to actually process those signals or not, it depends on certain criteria. So processing the electrical signals being detected on the wire is equivalent to processing the packet, because these electrical signals are nothing but these are 1010 bits, which eventually represents a frame or packet that is being traversing on the wire. So depending on certain criteria of L2 routing, machine B and machine D may choose to ignore these electrical signals, or they may choose to process these electrical signals. So example is that all machines in your college campus may form one subnet. So this is the example of a subnet, that all the machines of a hostel or all the machines in the same department or all the machines in the same college campus may be present in the same subnet. And all those machines must be sitting behind the one main L3 router. So you can see in this diagram, the machine A, B, C and D may represent the machine of your college campus. And those machines has to be behind one L3 router, which is called gateway router. So this is how the broadcast domain or multiple machines present in the same subnet are organized along with the L3 router. For example, the machine B wants to communicate some machine, let's say E, which is present elsewhere in the internet. Then all the data generated by the machine B will bypass the L3 router and it has to go through the L3 router through the internet. So whenever a machine in the one subnet wants to communicate with the machine present elsewhere, that is out of the subnet, then all the data transmission happens through the boundary or gateway L3 router of a subnet. So again, we will study all this formally when we will be doing L2 routing and L3 routing in the next module. So actually all this information is building up the foundation for and preparing us for learning L2 routing and L3 routing in subsequent modules. Also, the one point that I would like to discuss here is that whenever a machine which are present in different subnets wants to communicate with one another, then the data has to be forwarded through L3 router. So in this example, let us say that there is some remote machine E present elsewhere in the network, and let us suppose the machine C wants to communicate with the machine E. Now this is the example of communication where the communicating machines are present in different subnets. So all the data that is generated by the machine C will have to go through the L3 router, and there could be any number of L3 routers present in the network, and eventually the data reaches the machine E. Right? So the point here I am trying to emphasize that whenever communicating machines communicate, whenever the communicating machines are present in different subnets, the data has to pass through the gateway L3 router of the subnet. And whenever the communicating machines are present in the same subnet, then L3 router do not play any role. So L3 router is used only for L3 routing, that is taking the data from one subnet to another subnet. And when the communicating machines belongs to the same subnet, then there is no role of L3 router being played in taking the traffic from source machine to destination machine which belongs to the same subnet.